Hello, community. Let's talk about some new technology, some super AI agents, as Stanford calls them. Now, if we bring down the technology from the cloud here to on-device, edge devices, our phones, we have to modify our AI agents significantly. Two parts. The first part is about technology, Apple, Google, Stanford, and the second part is about coding. This is about OpenAI, Cohere, and Anthropic. So let's start. Yes, I know on your iPhone you have your OpenAI and your Anthropic app and whatever, and it connects to the cloud, and the cloud does all the combination and the computation and everything, and your phone is more or less just a keyboard and a screen that shows you the result. But we want to change this. We want to go really on device, on edge device, on your phone. And we focus today on a large language model with a function calling functionality on your phone. There's some beautiful new technology, and I know that you want to focus here on speed, accuracy, battery connectivity, but the most important fact is, of course, energy. Without energy, we cannot do nothing. A typical battery has 50 kilojoules, so this means for a 7B model on a phone, if it does a function call, it uses 700 joules per call. So this means after 71 function call, your phone is dead, your battery is empty. This is a catastrophe because a simple operation can have maybe up to 100 function calls. So great. We need new technology, particular here in energy conservation. So you notice that if I have a large language model with an extension to the internet, to databases, we're talking here about AI agents and not pure large language model anymore. Because we have the ability to interact with some external environments and even make decisions about the external environments. Beautiful. So here we go. Stanford showed us a new methodology to increase the energy efficiency of this system up to 3,700%. And this is amazing. How they do this? Well, think about it. You have an LLM on your phone. So of course you make it smaller. But the external world for this LLM is your operating system on the phone. So this means you have your emails, your photos, your video, all your document. With the financial and medical and career data, you have all of this on your phone. So the LLM, if it gets now a function call functionality to the operating system, to your personal documents, suddenly you have an on-device AI agent operation, and there's no transfer of data to the cloud. Now, for this LLM, those are tools that the LLM can use. So if you combine this, we get an AI agent. Beautiful. Please note, I'm talking here about an iPhone. I'm talking here about a Google Pixel phone. And you notice there is no Microsoft phone. And this will become important when we talk about ecosystem evolution. Beautiful. So, tool user also, as it was called here with OpenAI, function call is now something beautiful, and we implement it here for our LLM. And let's go here to Android and say we have now here the tool use for our Android System API, the Android App API, and the Android Smart Device Management API. For example, if your phone controls the lighting in your flat, or controls here the window in your house, or maybe your car, or whatever. So whatever you have a device management on Android, our LLM on your phone can control now whatever you wish to control with your voice. Beautiful. So here's a command. They say, hey, Google, analyze all my emails starting from December last year about my project communication with all my dedicated team members and write a short technical summary with a timeline. This is quite a challenging task, but this is easy if we have agents and not just LLMs without a functionality for functions, because now we just define function that the LLM connects now to your emails, the LLM connects now to your documents, the LLM connects now, and you get the idea. Beautiful. Ecosystem, Google has a phone, Google has an operating system, Google has an LLM, and we're going to use here GEMMA 2 billion free trainable parameter. Well, Apple has a phone, Apple has an operating system, and Apple builds now a new LLM. Now, what a coincidence. So here we are now in our strategic market positioning of Google and Apple. There's something beautiful because April 3rd, 2024, we have a publication by Stanford University on new technology regarding on-device language models for super agents. Now, of course, those language models are not large language models because they're rather tiny. Stanford uses here Google's GEMMA 2 billion, so it is not an LLM, but it's just now reduced to an LM. To have on-device LLM models for super agents. What can we do with a phone where the phone is controlling almost everything in our personal environment? And they showed, yeah, you can have the weather and you text here the result of the weather to your friends, and you can search YouTube for specific things, and the result you can mail or analyze further. You have all the functionalities now on your device. If you have your financial data or your private data, this will stay on your device and will not go to the cloud, which is completely different what is currently implemented. So how can we build super agent like Stanford calls it? Well, of course, the first part is a large language model, and we have GEMMA 2B from Google, plus, now this is the genius idea, some very specific fine-tuning where we introduce functional tokens to reduce here the energy requirement of the system that it can run on a phone. Now, GEMMA 2B, you know I have a specific video on this topic. Now, what are functional tokens? It is a rather simple idea. Now, at first, the LLM has to decide that I tell my LLM my task, what I want to do, and the LLM has now to decide which procedure to initiate. So, if we now have functional tokens that abbreviate our functions, now we have to train the system. And here you have it. Below is a query from the user. Here, query. This is my query that I have on my iPhone. And then you ask the LLM, please choose the correct function calling, and generate the parameters to call this specific function. If you call the weather, you want the location, and you want either in Celsius or in Fahrenheit or whatever. So you could have a single function call. You learn the system how to do this if you define a function that it can be done in a one single function call. If you search, for example, all of YouTube, maybe it would be good to have multiple parallel operations, multiple parallel workers working on this particular problem. Or if you have a nested function call that you have to wait, either you have a logical dependence or a timely dependence on another part of the program. So you have nested function call it. You learn the system here on single, parallel, and nested function calls. Now, of course, you have, if you have your function, and here, for example, you wanted your LLM on your phone get to trending news. Here you have now your detailed explanation what you want to do with this particular function call. So, for example, fetches the news article based on a category, on a region, and a particular language, the maximum result, what should be returned, and so on. You know this here from OpenAI. And of course, if I tell you we have to fine-tune GEMMA 2B, we need here a very specific training data set. And of course, Stanford uses Google Gemini to generate here the query and the function calls. Beautiful. So let's see how good is this system. And they built it and they assessed here the performance. But please notice we are now only focusing on a very special topic, on the agent's effectiveness in generating accurate function calls. So if I tell my phone, hey, do this on this job, is the phone able to find the right function calls to go to the operating system and perform the task, or go to the mail app, or go to my photo app, or whatever, and perform in sequence the correct task and come back with the answer that I ask it to do? Here you have the result as published by Stanford, the function call accuracy in percentage points. And as you can see, if we go with GPT-4, it has accuracy of 98.5%. Now, this little tiny beautiful Octopus version 2, not large language model, but language model on the phone, if you do a full classical fine-tuning, they achieve accuracy of 99.5. And if you have here a little bit of help with LoRa, a low-rank adaptation fine-tuning to be a little bit faster, you still get here a function call accuracy of 99%. So if you read now somewhere that Octopus outperforms GPT-4 in percentage, yeah, but please remember, this is for a very tiny, very narrow function call area. Because GPT-4 can do all of this. It has a spectrum of function calling of all of this. And then Octopus is only, and I mean really only, learned, fine-tuned for your phone for a particular task here on the Android operating system or an Android app or whatever. So Octopus can only do this little bit here of task performance. But in this small sector, it is really comparable here with GPT-4. And if you think GPT-4 needs, I don't know, a lot of energy to do this on an NVIDIA GPU in the cloud, Octopus is doing this on your actual phone, and it achieves here a slightly better performance. So this is an indication, yes, the technology is there, we can do this. In a very limited amount, but we can do it. But you might say, okay, this is the accuracy, and what about here the time delay? Now again, vanilla GPT-4 is down to 1 second here, function call inference time. And if you look now here at the LoRa fine-tuned Octopus version 2, it is 0.37 seconds. So it is, of course, here faster than GPT-4. But I think for GPT-4, it is quite fast if you think about this. So whatever GPT-4 is doing here in the cloud, my goodness, this is also amazing cloud results. Great. So there you have it. You have the accuracy and you have even a better inference time if you have your LLM on your phone. So this means for this very narrow corridor of your task that you do every day on your phone. So for your specific task on your phone, the accuracy and the time is absolutely comparable and maybe a touch better than any proprietary cloud-based AI systems that you can buy. But of course, please note that our tiny little 2 billion free trainable parameter language model is, of course, not as good in logical augmentation, and it has severe logical limitations if you compare it to a monster GPT-4 system. But this is to be expected. But we do not have to have on our phone everything from Italian literature of a French poem to British, I don't know, storytelling. We just need here to fine-tune for our daily task on our phone data, what we want to do and how we use our phone for. And you know what's beautiful? And now we come back to the ecosystem idea. Your iPhone can send your job that maybe it struggles to perform for energy reason on the phone chip to your MacBook Pro with a lot of shared memory, with a lot of VRAM. So if you have this ecosystem of phone to a laptop, there is the big question, will in the future a small little beautiful company or an individual, will they need the huge cloud infrastructure where the beautiful, extreme powerful NVIDIA GPUs and NPUs will perform the task? Or is it possible to bring it down here on a local laptop and to your local phone for your local task that will definitely enhance your privacy because it will never leave your local devices? So you see, there's an interesting question here that open up. If you have here the energy consumption, you can have a grip on this and you can optimize it. And I think Stanford has done a brilliant task to show us here, hey, think about your iPhone or your Android phone and think about here large language model or language model with function calling and what you can do with this on your phone. Because your phone you have every time with you. So there you have it, our new super agent as defined by Stanford on device, on an edge device, on a phone. And you could strategically make here use of the Apple ecosystem integration from phone to iPad or laptop, whatever is here your energy consumption, whatever is your compute infrastructure that you need, this could be here fluid transition here from one edge device to another device. And of course, the same is true here for Google's ecosystem, where you have a Google TPU, a tensor processing unit, and you have JAX and FLAX ecosystem for massive parallelization. So wherever you are and you have, let's talk about the upcoming Google phone Pixel 9, that will also have, I suppose, the next generation TPU chip integrated and technology is compatible. So those are brilliant new insights for the future, how we can use your phone, how we can use AI now on device, locally on a phone. But of course, we have to do this. So therefore, part 2, hello! Now we talk about code, OpenAI, Anthropic, and Cohere. And you know this GPT-4 opened up, I think about a year ago here, the function calling functionality. And it allows here our GPT system to connect here to external tools and API. Developer describe the function to GPT-4, have the model choose here the output to a JSON object containing here arguments to call those functions. And you know now a lot of LLMs have been fine-tuned to both detect when a function needs to be called, depending on the user input, and to respond with a JSON structure that adheres to the function's signatures. You know 2 examples here for the interaction with an application programming interface. For example, a query like, hey, what's the weather like in Boston? And you have here a function call for the function get current weather, or you have a SQL query and a specific function call. So we follow here the OpenAI cookbook, and you know the tool here is an optional parameter in the chat completion API, which can be used here to provide here the function specifications. Here's our tool. This is a function. We define the function, the name of the function. We get the description of the function, maybe a little bit more description here, please, because the system has to understand when it has to choose this particular function to do the job. Then you have the parameters, the property, the location, the format, the type, the description of each and every object, and the required parameters for this. You know this. And then, of course, you can choose if you have the chat completion request that you send off. You have your messages, you define your tools. And if you have defined a particular function that you want the system to use, and only this, you can even have here hard print and you say, hey, tool choice, my function is the function with the name get an end-day weather forecast. So it connects to a third-party API, and beautiful. Now, if you go to a SQL example, we also look at an OpenAI cookbook. You have the same structure. You have your tool, you have a function. The function name is now, for example, ask a SQL database. The description is, of course, specific. You have your parameters, your property, your query description, your database schema string. Required here, of course, here is the query. And you know this, so when you execute your SQL queries, you are familiar with this from OpenAI. Now, there's another company called Anthropic, and with Claude, this is a very special day here, because now with Claude, and I'm here at April 4, 2024, and Anthropic says here, hey, now available in beta to all customers in the Anthropic Messages API, you can now interact with external tools. So now we have function calling also with Claude, April 4, 2024, which is great. Yeah, of course, you have to subscribe, you have to pay Anthropic, but if you go there, you see in their documentation, you have now here the tool use. They call it tool use. This is exactly what OpenAI calls function calling. So you go there and you say, hey, public beta with 4th of April 2024, beautiful. So you can use this. We are now in day 1 of this. So what I show you is my experience of day 1. So you can imagine. But look, it is so similar to what we already know. Here in Python, you have your client, you have your respond, client, beta, tools, message, create. You have your model, your Claude 3 Opus model, for example, the maximum tokens. And again, the tools, you have again the name, for example, we get weather function. You have the description, what it does, gets the current weather in a given location. Now it's a little bit different. It's called input schema. And there you have properties like a location or a unit. You have the description and you have the required, and this is the message. And you see it is almost identical, but really easy if you're familiar with OpenAI. So Claude will return a response. And I think this is nice because you have here a specific token. Thinking tells you the assistant, I need to call now the getWeather function, and the user wants here to know SF, which is likely San Francisco weather. So it goes there, gets the weather. Isn't this beautiful? And there I have to smile because from the API it gets back here, the tool use gets back here the content. It has 65 degrees. And the final response after we incorporated this back into Claude, Claude gives us here now the final answer to the user, and it says here the current weather in San Francisco is 59 degrees. I had to smile. 65 degrees, 59 degrees. Maybe it's just a typo. Maybe it is a hallucination, but you see, hallucination can happen everywhere, even in the official documentation of Anthropic. What happens if an LLM has no function calling? And there is a brand new example, and I have to show you this. Cohere, and they have a new, extreme, beautiful LLM, Command R PLUS. Please notice the plus here. And I went there, and on Cohere platform, I say, hey, search for the latest archive preprints on AI agent, and a specified time, April 2024, and give me a short technical summary of the first 5 preprint on the archive server. And Cohere goes out and tells me after seconds, it's fast. Here, a short technical summary of the first 5 AI agent preprint from archive from April 2024. And if I would not have noticed that the title is beautiful, the author looked beautiful, but the link is a little bit strange in this notation. The summary is beautiful and it's coherent within. And if I see this without the link, I would have said, wow, great, it went to the internet and these are the real data. But you know what? It has no internet connectivity. So this LLM is so good that it understands exactly what I want. And it invents, it hallucinates, it creates out of thin air this data. Those are not real data. This is what a system gives me in response to my query. And it is perfect. It has the title, it has the authors, it has a little bit of strange link. It has a perfect summary. It is on topic. It is exactly what you're looking for. Zero generalization performance. The title looks interesting that you can have where you have here agents. So in the first seconds, I would not have noticed this, especially if you leave out here a specific actual time frame. And next time I said, search for the latest archive preprints on AI agent and give me a short summary of the first 5 preprints. Now, the system was not limited to April of 2024, so recent. And look, now it gets me an answer that is just amazing. We have the title, we have the author, and we have a real archive link. But this title does not exist. This author might exist, but not with this title. And this link belongs to another document. And this description is coherent in the topic, so the AI hallucinates perfectly, but it is just the shape and the form that the LLM is generating here for me, but with a hallucinated content. But isn't this a perfect answer? If I would have seen this as my first answer, I would have been sure that these are the data from the internet, from the archive server, and the LLM is doing its job and giving me here back exactly what I want. But notice, all of this is hallucinated. But the system is that good that I was really amazed. So whenever we have here then Cohere, will provide here the function calling Command R plus LLM plus function calling or whatever they will call it, tool use, advanced tool use or whatever. I think this LLM will be amazing. But my goodness, you have to be careful if you work for the first time with those agents. So there you have it. Isn't this beautiful? But of course, if you're interested here in technology and you're interested here in market, you might say, hey, what are implications for NVIDIA? Because NVIDIA is building here all these beautiful cloud NPUs and GPUs and AI systems. And you might say, what is the strategic position of NVIDIA in this ecosystem? And the question I ask myself is, hey, as NVIDIA, can you scale down your data center GPU technology to new edge devices? Can you just scale down technology? Is this possible? Or do you have to invent complete new on-edge technology for this? From a technological point of view, it is fascinating. And of course, we have another player I have not been talking about, and this is Microsoft. And for Microsoft, the question is now, yeah, you have now on every Microsoft laptop here the Copilot button and connectivity and everything. But can you scale up your market without a phone? And particularly without a phone ecosystem, Microsoft. I think for Microsoft, this will be an interesting question. Either it will create a Microsoft phone to have this missing part of its technology ecosystem, or Microsoft will decide to go without. But there are a lot of strategic options and new technology implementations for this that maybe we will talk about in a later video. I hope it was informative, and it would be great to see you in my next video.